Bismillahirrahmanirrahim. In this video, I'll try to explain you that what is a potential divider. Before making you understand that what is the potential divider, I would like to explain you the resistances which are connected in series. Now here I have taken two resistances. Say one is R1 and other is R2. Say it is 5 ohm resistance and it is 3 ohm resistance. So it is very important to understand that how these resistances, when they are connected in series, how they are dividing this 12 volt potential across them. Okay. So whenever the resistances are connected in series just like this, you must keep in your mind that the current flowing through them has a single path. So this is the path of the current. So when the current is passing, in the passage of the current, this 5 ohm resistance and 3 ohm resistance are coming in the path of the current. Okay. So it means totally how much resistance this current is facing. So that is R total, or simply the R which this current is facing, is the sum of R1 plus R2. So keep in your mind, whenever the resistances are connected in series, to find out the total resistances, we have to add up these resistances. So keep in your mind that whenever you are going to find out the total resistance of the complete circuit in series, you will have to add up these resistances which are connected, whether they are 2, 3, 4, 5, etc., etc. So as many resistances are there, so you will have to add up them. Okay. So here I have only two resistances, so I am adding only these two resistances. If you are having three or more than that, so you are going to add them like this. Okay. Now here you can see that R1 is 5 ohm and R2 is 3 ohm. So the total resistance R will be equal to 5 plus 3, 8 ohm. This 8 ohm will be the total resistance of this circuit in series. Now, first of all, before finding out that this 12 volt, how this 12 volt is divided across this 5 ohm resistance and this 3 ohm resistance. Okay. So we are going to find out that how many volt this 5 ohm resistance is drawing from this battery and how many volts are being drawn by 3 ohm resistance. Okay. So this is our main target. So please keep in your mind that what we are going to do. So to find out the voltages across these two resistances, because this 12 volt potential difference is not totally given to each of them, but it is divided according to the resistances of 5 ohm and 3 ohm. So how they are being divided? So you know that according to the Ohm's law, according to Ohm's law, that V is equal to IR. This is the formula for Ohm's law. Okay. Now here we have to find out the current. First of all, we have to find out that how much current is flowing through this circuit. You know that I told you earlier that current has only one path to flow. So throughout this path, the same current will flow. Here we can also introduce an ammeter. A stands for ammeter. So ammeter basically it measures the current. Okay. Now from this formula, I is equal to V over R. Now I have already calculated R, which is 8 ohm. Now I am applying the values. The V is 12 volt. So this 12 volt is the potential across this complete circuit. 12 over 8. By dividing it, we can get 3 by 2 or 1.5 ampere. Now we have calculated that 1.5 ampere of the current is passing through this circuit. Okay. Now if I am applying a voltmeter here, you know that whenever we are connecting a voltmeter, it is connected in parallel through here. Say it is V1, voltmeter 1, and here I am introducing another voltmeter which is V2. These voltmeters are connected in parallel with each of the resistances. For resistance R1, I am applying the voltmeter V1, and for the resistance R2, I am applying the voltmeter V2. Now I will have to find out that out of this 12 volt, how many volt are given to this R1 and how many volts are given to this R2. I have already calculated the current. You can see that it is 1.5 ampere. Now I am going to find out the reading on V1. You know that from this equation V is equal to IR. So for finding out V1, V1 is equal to IR1. Here I will take IR1. I is the same as I told you earlier, that throughout this circuit the same current will pass. The current will be the same throughout this circuit. Only this R1, because this R1 is different, which is 5 ohm. So apply the value. I is 1.5 multiply R1, which is 5, by multiplying these two. By multiplying these two, we got 7.5 volt. Okay, so we got that the current voltage of 7.5 is given to this 5 ohm resistance. Now, if you are going to find out the voltage of this R2, then the same formula you will have to apply. For V2, V2 is equal to IR2. Or simply you can minus from 12, you can subtract 7.5, even then you can get. Here I am applying the formula. I is 1.5 and R2 is 3. It is 4.5 volt. So here you can see that this 12 volt battery is giving 7.5 to this R1 and 4.5 volt to this R2. If you are adding up these two, means 7.5 and 4.5, you can see 12 volts. So the total of these two is 12 volt, which is this. Okay. Now with the help of this example, it will be easier for you to understand that what is the meaning of potential divider. Now I am going to give you the example of a potential divider. So I told you that how the potential is divided when the resistances are connected in series. So I told you that if the resistance is higher, then the potential difference across that resistance will be higher. If the resistance is of low value, then the potential difference across that resistance will also be low. Here again I have shown you another circuit in which two resistances are connected in series. 12 volt potential difference is given to that, and these are connected in series. The current flowing through it is like this. Okay. Now if these two resistances are of equal value, then obviously each voltage, like V1 will also be 6 volt and V2 will also be 6 volt. Roughly you can understand that if the resistances, both the resistances are equal, then voltage across each will be equal, because sum of these two voltages must be equal to 12 volt. This I told you. Okay. Now how the potential divider works, what is the use of the potential divider, we have to understand here. Now I am going to explain you that why we need a potential divider circuit. For example, you have a 12 volt battery and you want to operate a 3 volt LED. This is a 3 volt LED which you want to operate with the help of this 12 volt battery. Now if you are directly connecting this 12 volt battery with 3 volt LED, so it will blow out. Okay, it will burn out, it will not work. So what we have to do, we have to adjust the resistances in the circuit such a way that we can get 3 volt potential difference across this LED, so that it must operate correctly. So here we will not connect it directly with the battery like this, and if I am connecting it with this like across this, then this is giving it 6 volt. Even then it will burn out. this LED will burn out, and even 6 volt are not useful for us. Now, how much R2 must be? Now, there is a formula. Actually, this formula is according to the Ohm's law, but a simple form of this formula is this, that how much R2 must be. Now, this is volt in, which is 12 volt, volt in, which is 12 volt. Now, how much volt we need here? We need to take out, say, 3 volt. Here I am applying volt out LED. Now, how much resistance I must apply here so that I must get 3 volt potential difference across this LED, this volt out. Now, for that purpose, I use the formula that V out is equal to R2 over R1 plus R2 into V in. This formula. With the help of this formula, I can calculate that what must be the rating of the resistance here to operate my 3 volt LED properly. Now, how I am going to do this? I know that I need 3 volt potential difference across the LED. Now, what I am going to do? Volt out, I want 3 volt. So, here I will keep 3 is equal to R2. R2 is required to be found because I don't know that how much is R2. So, here instead of R2, I am putting the question mark. So, R2 will be kept as it is. R1, you know that I am taking R1 as 5 ohm and R2 is not known, and the volt in, the voltage provided to this battery is 12 volt. Okay, that is volt in. Here you will keep 12 volt. Now, you will have to solve this equation according to your own convenience. By solving this equation, you can get that R2 is equal to 5 by 3 ohm. It means R2 must be of 5 over 3 ohm to get the potential difference of 3 volt for this. So, this is the purpose of potential divider. Now, let us consider another problem. Now, here in this problem, you can see that this R2 is known, which across this R2, I need 3 volt. Okay. But here, I don't know how much R1 must be so that only 3 volt must be carried to this 3 volt LED. Now, here you can see that first of all, we are going to use the same formula, but here this is 3 volt. Out of 12 volts, if we are subtracting this 3 volt, we get 9 volt. Okay. So, here it means the voltage across this must be 9 volt. Okay, because we are going to find out that what is R1. So, we must know that voltage across this must be 9 volt because we need only 3 volt here. So, out of 12 we have to subtract this 3 volt. So, remaining volt must go there. So, how much must be R1 to get this 9 volt? Okay. So, here R1 is required to be found. So, in this way, this equation will be like this. Now, how I am going to solve? You can solve it according to your own convenience. Now, here you can see that I have placed this 9 volt here, okay, according to the formula, and I have solved this equation. By solving this equation, you can also solve the equation according to your own convenience. So, I got the result R1 is equal to 24 ohm, okay. So, here R1 must be of 24 ohm, so that 9 volt must be drawn to this terminals, and across these terminals I can get 3 volt. So, in this way you can also use the formula of the potential divider. So, you must keep in your mind the formula, that how this formula can be utilized.